Endothelial cells that line the interior surface of the blood vessels have many functions. For example, acts as a semi-selective barrier between the vessel lumen and surrounding tissue, control transit of white BC into and out of the bloodstream, prevent blood clotting because it contains heparin sulfate, which acts as a cofactor for activating antithrombin. Damage to the endothelial cells or loss of proper endothelial function lead to serious problems and is a hallmark for vascular diseases. There are many things that cause damage to the endothelial cells, and one of them is hypertension. Hypertension means increase of blood pressure, that's the pressure of circulating blood on the walls of blood vessels produced by pumping action of the heart. Hypertension has two types: primary, which means the underlying cause of the condition is not clear, and secondary, that has certain causes. The causes of hypertension is varied. Some of them are genetic. For example, polycythemia vera is a genetic condition in which the number of RBC greatly increases, and one of the complications of the polycythemia is hypertension. Hypertension also related to the physiological condition. For example, pregnancy and normal individual aging. Lifestyle also has great importance. For instance, obesity and intake large amount of salt, especially sodium chloride, cause increase of blood pressure. Anyhow, when there's increase of blood pressure due to any reason, there's an additional force on the walls of blood vessels, and over time, this additional force leads to damage to the endothelial cells. When endothelial cells are damaged, they secrete many chemical signals, for example, tumor necrosis factor alpha, interleukin 1, interleukin 6, and interleukin 8. Through these signals, it seems like endothelial cells need help. But who knows? Maybe sometimes the helpers make the situation even worse. Let's figure out. Damaged endothelial cells increase adhesiveness and permeability of the endothelium for cholesterol, platelet, and leukocytes. Cholesterol is a type of lipid bound to the lipoproteins and circulate in the blood that has many functions. Cells in our body need cholesterol, for example, for cell membrane regeneration, cell division, and synthesizing hormones. But when the amount of cholesterol arises in the blood in a manner that exceeds cell need and requirement, excessive cholesterol is deposited in subendothelium. In fact, if the amount of cholesterol is too high in the blood, cause deposition of the cholesterol in subendothelium without depending on whether the interior surface of the blood vessel is healthy or not. But rough surface of the interior vessel wall speed up the process and cause more attraction and deposition of the cholesterol. When cholesterol is deposited in the subendothelium, they change their forms and become oxidized cholesterol, and they produce free radicals that damage the vessel wall more. On the other hand, through the chemical signals secreted by endothelial cells, monocytes, which are the first defense line of the body, will be alerted. As soon as the first monocyte is alerted, it encourages other monocytes to be warned too. Monocytes migrate toward the damaged endothelial cells, and when they arrive to subendothelium, they differentiate to macrophages that engulf oxidized cholesterol. In fact, macrophages engulf any substance produce free radicals in the body. If the amount of oxidized cholesterol is high, then macrophages engulf more and more cholesterol, and they become foam cells and push the endothelium. If the process continues, many inflammatory responses happen, and two more important chemical signals are secreted, that they are fibroblast growth factor FGF, that is secreted by endothelial cell, and platelet derived growth factor PDGF, that is secreted from the foam cell. These growth factors attract small muscle cells and migration of them from tunica media to the tunica intima, and stimulate cellular migration and proliferation. Cytokinins secreted by macrophages also stimulate more migration of smooth muscle cells into a subendothelium. Smooth muscle cells synthesize collagen, leading to formation of fibrous cap. Smooth muscle cells also accumulate more cholesterol and form foam cell. This complex of smooth muscle cells, cholesterol, foam cells, and macrophages form a plug that make the blood vessel narrow and narrower over time. When the blood vessel becomes narrow, only small amount of blood can pass over the plug. But if the condition leaves untreated, cause even block the entire vessel and stroke happens. When there is block of the vessel, so blood cannot reach structures behind the plug, and when there is no blood, mean there is no oxygen and nutrition. And without these essential substances, cells start to die.